per hour. And also there is a status here to know about the connection status. Yeah. So the features of these products is temperature measurement, oxygen saturation, heart rate, respiration rate, and also the some other parameters regarding to the lung quality, like forced vital capacity, peak expiration flow, and forced expiration volume. So these are the specification of the device that we designed. So this is the device. We are in collaboration with University Airlangga and also University of Pajajaran. So this is how it looks like. So this is a temperature, yeah, and these oximeters, and this is a device that has a disposable mouthpiece. And there is two modes for this device. Yeah, it can in monitoring mode. In this mode, we can monitor continuously in real time, like a respiration rate, temperature rate. Yeah. And the second is a spirometer mode. So this mode will work as a spirometer in order to check the capacity of the lung. Yeah, we are afraid that the lung there is degradation due to the COVID-19. So this is how the block diagram. So there is a little bit changing in the designs. So the people will go to the flow meter, and we monitor using turbine, yeah, in the current system. And then there is main control using the microcontroller. And also there is a pulse oximeter doing acquisition of the oximeter, the saturation, and also the body temperature. Yeah. And then this as a system, we can see it's like this. So this device used by the patient. Yeah. So this device is direct contact with the patient using temperature sensor, SpO2, and respiratory sensor using the mouthpiece here. And also it has a Bluetooth and Wi-Fi connection. And for controlling this, we designed the application using the Android application. It can we can see the parameters here, yeah, and also control start stop, yeah. And also there is a dashboard. Dashboard is for the doctor, yeah, and also the patient itself, yeah. This work as a medical record, yeah. And doctors also can give a comment on the patient situation. So this PCB that we designed, you can see here, there's a microcontroller here, and there is a Wi-Fi, and there's a turbine here, yeah, and there is a battery, and there's a connection for SpO2 and connection to the temperature here, yeah. If we see in three-dimensional, you can see it like this. And after implementation, you can see it using a two-side PCB, yeah, how it looks like, yeah. And this is how to use this device, yeah. This is a PCB that already integrated with the mouthpiece. And then this system, so this mobile application work with the Wi-Fi. Yeah, and this is Respinos, we call it, the device is Respinos. And all the data we can check in our website, yeah. And so there is data sending from the Respinos to the device directly using Bluetooth, or it can send also to the Wi-Fi. Yeah. And this is how it's used, yeah. When we're using monitoring mode, yeah. So we can turn on the device and doing a pairing and connect with the sensors, yeah, the SpO2 and the temperature sensors, and also the mouthpiece, yeah. And then we connect to the finger for the SpO2, and then to the and then to the mouth for the mouthpiece. And then you can respirate, yeah, normally. And then we can see the measured data on the application. So this is in monitoring mode. And this in spirometer mode, yeah. The first is the same, you turn on and then so you pair and then you connect the mouthpiece and then you do measurements by under supervision of the doctors. And the result you can see on the dashboard. Yeah. Okay, I would like to show the design that we have made for this device. Yeah, this is a three-dimensional design. So this is the device. If we open, you can see that there is a PCB, yeah, battery, and then this encoder, decoder for the rotation detection. And this is when the device is already finished. So you can check in the website. So this is a real time, yeah, in monitoring mode. You can see the respiration rate, saturation, and temperature. Yeah. So this oximeters. So it's designed for the teleconsultation. And in the website itself, we also designed something like a registration system. So the user can register their new device here to connect the Respinos. Yeah. And also the doctor also has to have an account. Yeah. They put their hospital and this is a confirmation of the emails. And you can log in again to check your data. So this is your data, yeah. And then some for the medical record, yeah, after finish using this, you can check when you do a monitoring. Yeah. This parameter of spirometers. Yeah. And also doctor can do review of the condition of the patient. And then for the patient itself, I think it's the same. And we also demonstrate our in how to use it. This with a doctor in Hasan Sadikin Hospital in Bandung. So we demonstrate how to do monitoring. And this during spirometer, since this is a little bit difficult, so you have to blow your very fast, yeah, and check your lung condition. So this is the graph, yeah, the condition. And then this is our experiments, how to measure the heart rate, the respiration rate. Yeah, sometimes there is a problem that's the data is not consistent, so we have to overcome these problems. And then this our benchmarking, between our device and its commercial one. So it seems is okay, and is the error percentage, and then for the temperature, we compare with commercial temperatures quality with the flow and also with amulets. So it's sort of consistent output. So this oxygen saturation, we also measured and compared with the other commercial products and also their heart rate. You can see that the difference is not so much. So we calibrate and check the quality of the heart rate, and also the oxygen saturation using standard device like this, in order to make sure that our design is proper for this. Yeah, you can see that saturation shown here and heart rate, is almost similar. We do bring comparison. And then for the spirometers, in order to measure the volume, we're doing a testing like this. This is standard, for measuring the volume. So this actually showed how much. And then we do medical testing directly to the COVID patient. So this COVID patient, we measure in hospital. Okay, as a conclusions, we have designed a portable device that can monitor respiratory condition and important parameters for COVID patient, and has been successfully designed. The device can monitor the patient condition in real time via the cloud, thereby reducing the risk of contact for health workers. The device can also be used to see the lung condition of post-COVID patient. And this device is designed, device to use Internet of Things technology. Okay, thank you. I think that's all my presentation.
Okay. Thank you very much, Prof. Trio, for giving us the interesting and informative presentation. Okay, the next session we have we invited the third speaker, Honorable Dr. Majid Khan, for the third presenter. So I will call Professor Dr. Majid. Are you ready?
Assalamualaikum and good morning, Teh. Yeah, I'm ready.
Waalaikumsalam. How are you today?
Good, good.
Very good. Okay. Okay, Dr. Majid, you can deliver your presentation. Yeah, Dr. Majid is from University Science Malaysia. Yeah, with topic in the artificial intelligence in COVID-19 era. So, okay, the screen is yours, Dr.
Okay,
Majid.
thank you very much. By the way, I would like to thank to Prof. Alan and also Prof. Trio for a fantastic presentation just now. My presentation is not fantastic as them, but let's go through together.
Yeah.
Let me share the screen. Please host able.
Okay.
Please able me to share the screen.
PIU ISDB, can you change the host now?
Okay.
Parol. Yeah, yes.
Okay.
Okay, Dr.
Okay,
Majid.
thank
Okay.
you. Thank you very much. Okay, let me go through. Okay, Assalamualaikum and very good morning to all of you. My name is Majid here. And what I'm going to present today is actually about artificial intelligence in transdisciplinary research. But most of the research will go through into agriculture before we move from agriculture to many other fields that are the online projects going on. And I would like to share my experience, and also would like to call all of you to join with me if you are feeling that would like to join with the projects. Okay, so basically before I go into the presentation, I would like to just like advertise about my school. The School of Mathematical Sciences, established in 1974, it previously known as Mathematical and Computer Sciences until the separations. And our vision is actually to be recognized department of mathematics that can attract excellent students and produce quality mathematician and also a computer scientist nationally and internationally. And our mission to lead and innovate in achieving excellence mathematical sciences at the international level through advancing and disseminating knowledge. So if any of you want to continue postdoc, PhD, master, or even undergraduate, please come to our university. And one of the good things of our university, we have a bulletin called Malaysian Mathematical Sciences Society. This is journal under our department, and actually currently our Q1 with top 1% quantile. And currently we just received the impact factor for 1.68, which ranked the bulletin at 30 from 470 journals in mathematics. So please come. So why we need collaborations, especially with mathematics department or USM? Because from projects that going on that are what I'm going to present today, a lot of the projects we are using machine learning, artificial intelligence, and from there we can do forecasting. And with collaboration with PPSM or USM, is not only going to get internalizations, recognitions, networking, and also we can easily to find a funding. So that's why I'm saying everything is possible with mathematics. Okay, let's go from my talk. Basically, I'm just going to present what is current ongoing projects that we are deal with. Well, a few international based companies, and what the project that involving artificial intelligence, especially during the pandemic. Okay, so based of first of all, one of the project that currently was appointed as the head of consultant with McCormick, that based on Los Angeles. Actually, it's a herbs company. Currently, they bought 500 acres in Malaysia to do development for black pepper drying system. So as mentioned by Prof. Ellen regarding the DC and AC regarding the solar panel, basically we are applied that solar panel for a mechanical dryer, and from the simulation and also from the quality analysis, we can able to explain to the McCormick what the good use of the current dryer. Okay, so basically we know that black pepper, also known as lada hitam or lada putih in Malay, or called white pepper or black pepper. Basically, they are involved with low skill and not hygienic drying, and it is involved with seasonal productions. And most of that drying process will take up to 20 days and usually low quality. So we collaborate with. That's why McCormick, very well known for spice and herbs, come and approach us to do a drying system to dry around 50 tons of black pepper per day. It's not a small quantity, but 50 tons per day. So that's why we involve with a lot of machine learning and how we use that machine learning in agriculture, and finally, what we're going to do after we get the data from sensor. Okay, so basically, first of all, we will comparing with conventional lab drawing, basically, which we're using a lot of sensor. And after we understand the quality analysis from the drawing, we use that that result and start to construct the dryer, because this fundamental knowledge is very important to do any mechanical dryer. And when you already start to dryer, definitely you can start to do on artificial intelligence on how you can monitor your system to be more efficient and more practicality. So this is black paper that's signed by McCormick from Terengganu, one of the state in Malaysia. So from here, we try first in our oven drying system to understand the physical drying characteristic before we start to do a simulation of the dryer. Okay, and when you are talking about dryer, okay, I love to talk regarding dryer because I hope, I think there's noise behind the, can anyone just mute?
Yeah, please mute the, hello. Okay, okay.
Okay, thank you very much.
Thank you.
Okay, so first, before we do any of mechanical dryer, or you want to control the system of any drying system.
Hello, hello. Hello, can you mute?
Oh, I'm
Hello.
sorry, I cannot continue without muting the.
Yeah. Yeah.
Okay, so first of all, we need to find what is the oh my God.
Hello. Please mute the.
Apa sih? Konsep. Oh, olahraga.
Halo.
Rizky Alan.
Rifki Alain, cucu Atika, please.
Bikin kayak gini dulu nih, please nama komuni 1 2 3 4 5. Nanti ini dibagi.
PIU ISDB, you can handle it. Hello. PIU ISDB, you can handle the house. Hello.
Farul, bisa di-mute gak itu yang lain kecuali speakernya?
Halo.
Farul, bisa di-mute gak itu?
Harus kosnya dari Pak Majid, Pak.
Dr. Majid,
Yeah.
please you change the host to PIU ISDB now.
How I need to change the host?
You can click the PIU. You can search in the find in the participant. PIU. Yeah.
Which one, yeah?
Or my name, Rocky Alfan.
Rocky Alpha. Okay.
Yeah.
Kalau gue nilainya begini sih 3,3. Jadinya kalau misalnya 3,62 ini A.
Rocky ya?
Yeah.
4 B plus gitu. Ini mah 8,3 sampai 3,6.
Make host. Okay,
Yeah,
make
make
host.
host. Okay. Okay. You can continue, Dr. Majid.
Thank you.
Please.
Thank you. I'm sorry. So let's continue. Next, before you find any mechanical drying system, you need to find first the optimized condition inside the dryer or outside the chamber of drying. Because after you get every particular decisions and finding the optimized conditions by using sensor and artificial intelligence, now we can design a different type of model. And from that design, you can optimize the pressure trajectory. And from the pressure trajectory, then you can have the drying behavior. We can understand the drying pattern. And from that drying pattern, we can start to design the solid collector. And from there, finally, we can find the uniformity of drying. And also we need to find of energy balance, energy and exergy balance. And finally, we are doing on quality. Quality. For this case example, I took for black paper, but after that, I will show with many other projects what is going on. And this is some of the simulation using artificial intelligence. When we have a different condition of parameter inside the dryer, we can see clearly what happened when we have a different trajectory. I'm sorry. when we have a different trajectory. So we can see when we have a different trajectory and different intelligence system that we can implement into the drawing design model, the flow of the air or the hot air are totally indifferent, and basically it gives us idea how we can try our agriculture product efficiently without depending a lot with labor maintenance. And this is another type of side view. Side view, what will happen when we have a different type of platform, because previously we are using drawing is just a simple single platform, but now it is totally will be different, and we need to start to optimize when we have a drawing system using tray. Just now it's only a platform, now we are using into a tray. So in agriculture or aquaculture, a very important idea is how you can control a few important parameters before you use that parameter to design your system. And finally, from your system, you find the energy and exergy analysis. So basically, when you already do a very good system, example, this is a simulation model with what we are going to do and fabricate for McCormick for 500 tons of dryer. So basically, they agree to build and they understand the artificial intelligence behind the system and what we can do. And finally, they pay us around $200,000 just to build up the dryer. So that's why I'm saying artificial intelligence play an important role in every simulation, and especially in agriculture and aquaculture, with getting a lot of data or called as big data. So this is another dryer for another type of project with the same company. And now we are using green effects without solar collector, and we call this one as a green effect dryer or greenhouse dryer with alternative solar collector at the ground compared to the top layer. So here we also can talk regarding the importance of artificial intelligence, and especially if we look here, we can see the pattern. The pattern of air temperature, which is very important for any mechanical dryer or mechanical designer to do the design before we can fabricate the design into the prototype. So this is what happened. Actually, we can look, although this is just a greenhouse solar dryer, but it able to dry the agriculture product into, and we can see that the temperature here will take around 88 degrees, and it goes up to every tree. This is very important because not many agriculture or aquaculture post-harvest will or can make drying system to be efficient until like this without understanding of artificial intelligence. So this is another type of dryer. I just want to give an exposure. We can do a lot of dryer, and we can see the temperature distributions is not good as what we have in the previous model or in this model compared to this model. And from here we need to understand artificial intelligence also play a vital role in determining or understanding the flow of temperature or the flow of the hot air. Although you have a very complex system, it doesn't mean your system will be efficient compared to those dryer that don't have a complex system. So from here, we can easily recommend that the model or our previous model is far more better compared this one. So this is one of the important of agriculture in black paper drawing system. Okay, so next I'm going to show all of you what is ongoing projects. I know all of you know what is this. This is called, in Indonesia, it's called rumput laut or seaweed. In Malaysia, it's called rumpai laut. Okay, so basically, currently I'm doing a project with seaweed research unit in developing the seaweed productivity in Malaysia. I'm not a biologist, but they make me as the head of consultant to do the simulation, to do the system, and finally to do the cultivation system in Malaysia, just in order to increase the productivity. And one of the problem that we can still look at the Malaysia seaweed industry, it is still low scale and low productivity. Some of the seaweed have the seasonal productions. The drying system, as usual in the 4 hours, play a very vital role to extract the carrageenan. Carrageenan is basically the product that we extract from the seaweed after it dried. So one of the important issues here that we need to understand is regarding the low scale, low productions, and low seasonality with the low drying skills. So that's why we are coming over and using artificial intelligence system in order to do seaweed farming using high density planting, tissue culture from our lab, modeling, parameter optimization, efficiency, productivity forecasting, and also on techno-economic analysis. We also integrate this project with seaweed and lobster to find as alternative backup income for the industry. And finally, definitely we need to look on the heat pump solar drying system that we modified from scratch, and finally now currently being used by the community to dry 500 kilo of seaweed for every batch of the drying. And from that good drying 4 hours method, we managed to find a good carrageenan and finally being used in a lot of industry in Malaysia. So this is one of the ongoing project, and definitely when we are talking about artificial intelligence, it's not only regarding on mechanical dryer or in control system or in the industry or a lot of industrial field, but also we also can use our intelligence system to control the room condition of tissue culture, and from there we can make sure the productivity of seed or the seaweed seed or seaweed seed through tissue culture can be obtained. Okay, and we can control the condition until we can get a breakthrough in the world regarding the seaweed productivity. So this is what is going on in one of the lab of my lab in Malaysia. So if some of you are really interested, want to do optimization using more artificial intelligence system into the model, welcome all of you. So next, continue. So this is the tissue culture base that get the condition using sensors from artificial intelligence. And by the way, we even can do the image processing of every species of seaweed using artificial intelligence, which is very important in identify disease-resistant seaweed. Okay, so because I just bring seaweed because seaweed also very important for Indonesia and also important for processing companies like in US. Okay, so this is our semi-farming at high density planting. But for me, I'm really much interested in what we are doing on the breakthrough using artificial intelligence, where we are the one in the world managed to produce the seed of tissue culture and using combination of artificial intelligence, which we just need around 45 to 75 days to bring a particular tissue culture seaweed, a good tissue culture seaweed from artificial intelligence back to the sea. Okay, and this is also another online, ongoing research regarding sea grape, okay, regarding sea grape, where we are, or we call in Indonesia as lato, okay, lato or lactut. So we are using this one for alternative supply of food. And here, definitely, we also develop our own database or our own data software for identifying the condition and also using that condition to forecast in the bigger system with integrated with lobster. So definitely, if you all coming to Malaysia, or if you have chance to come to my farm, please do. I will show you what we are going, what we are currently going on. And this is another project also in aquaculture. So in aquaculture, so what we do, we are also doing using artificial intelligence and forecasting using our own database to predict the water quality modeling, growth efficiency, forecasting for barramundi, for tilapia, and also for cod. Okay, and also we are doing for wanami. So this is for wanami. Currently, I have 4 farms of wanami pond in Penang. So I would like to ask all of you come. Look, I'm a mathematician and also a mechanical designer, but we can integrate. This is the importance of why we should have artificial intelligence, especially to predict the growth, the water quality modeling and forecasting. So in order, although we are in the pandemic, we still can operate our operation as usual without depending on the labor or any other factors. So this is another another model of drawing that I'm currently doing for Philippines. Okay, so currently what I'm doing with Philippines about the dryer to dry the seaweed. So this is actually proposed by the Philippines government. They paying us and we develop the model, and basically this is another new breakthrough model that I do from scratch, just using simulation. Basically I'm using CFD analysis to show you what happened in terms of the temperature, and basically this is used by them to dry to dry the yam. Okay, to dry the yam. So basically we are not looking at the aquaculture, we are also looking at the agriculture and also associated field. Okay, so this is another ongoing project. So the good thing about this is another project that we have already done. We already give back to the community. This is a seaweed project based in Sabah, Malaysia. So basically we create a model called V-Group Hybrid Solar Dryer for seaweed. Here we will be using the energy exergy analysis, and also we manage to do a breakthrough in the seaweed, especially to dry the seaweed with a better quality, hygienic, and definitely with a lesser drying period. And if you look here, this is the model. So actually, this is my first seaweed model. After that, I have a lot of new coming on projects. Okay, so this is the model. It actually can dry 5 tons per batch. 5 tons per batch within 7 days, depending of average of water per meter square or parameter or solar radiation of 650 watt meter per square. Okay. So from this dryer, what we do basically, why I'm going to explain this one in detail, because from this dryer, what we have done basically, we use our IoT application. I use my own IoT application where we do our own artificial intelligence algorithms, and also from that algorithm, we make sure we make it mobile, so that we doesn't need any labor to be there to do to wait or to do anything during the drying, because we can control everything just from our phone or from our computer. So it doesn't mean we need to be there. We just can be in, let's say you are in Indonesia and you want to control in Malaysia drying system. As long as you have the algorithm, you have the drying system and also the database and also the coding with a portable mobile, you always can record the data will record it automatically, and also can monitor the system efficiently. Example, if the temperature are too low, maybe due to the raining season, what will happen? We have heating element in the system which will be heating up to make sure that the blow that air blow from the heating element will produce more hot air to be used to dry the seaweed. And let's say if the system are too hot, we can use more fan to reduce the hot air in the chamber and make sure we have automated ventilation fan. During when we have the type of artificial system that we need to use and we have a portable software, definitely we can record the data. And the data is not saved in the computer or in the phone, but actually it's saved in the cloud, in the database cloud per second data. Just imagine when we have a per second data for every batch, we can use the data with all the parameters that involve as a big data. And definitely that big data, we can do a lot of things like forecasting, like in the research, like using for investment, even to calculate the return of investment, which is very important as agriculture or aquaculture practitioner. So this is an example. I have around 30 variable with 400,000 data. This data only taken for one day. That's why I'm using Excel. But in the cloud, you can keep how many millions data that you want. And the good thing is from the data, currently got one student, which also from Untirta. His name is Mr. Mukhtar. Mr. Mukhtar, although he's doing using a lot of data and using machine learning and artificial intelligence to do the predictions of the model. And currently he's already finished his analysis. He's writing up the chapter and going to submit as soon as possible to get his doctorate. And I hope he will bring back the knowledge that he learned from me and bring back to the university to help the university to do more machine learning based procedure. And this is some of the results where we do a clustering. And from the clustering, we also using some of the machine learning like random forest and KNN just to do the predictions of the model from the given data from the cloud. And from here, definitely, we can do a lot of research, especially on missing data or data that not accurate, which currently in the world, what they will do if you have a missing data or data which is not currently given the value, they will just ignore the data, which is not good for the prediction. So this is another type of machine learning called lasting net. And last not least, this is another type of heat pump that we just do for Singapore. Okay, we do for Singapore, same, we using artificial intelligence. So this is to try what we call asam cupping. Okay, asam cupping. So we are doing, and also we do for stevia. Okay, the same dryer also booked for another by another company, also from Singapore, to dry the stevia. The good thing of this dryer, when we can use our image processing and artificial intelligence, we definitely can preserve the color. Compared to the open sun dried. Same goes to the stevia. Okay, this is the fresh stevia and this is dried stevia, which still we can control the color. And the good thing of the big data, we also can do on business proposals or return of investment and also cost benefit analysis. That's why big data is very important when combining with artificial intelligence. Okay, so finally, from the cost benefit analysis, we can determine what will be the benefit and cost according to the return of investment or and also the interest rate that given by the banks per year. And that's for agriculture and aquaculture. Now, I just want to deviate a bit from what is ongoing project also in Malaysia that we are doing road safety for low and middle income countries. Basically, this is a conducted project with computer science and also mathematics. What we are doing currently, we managed to develop a base system like waste. Okay, like waste by integrating artificial intelligence. And I'm still need a lot of contributor or researcher. If you have interest in this project, please do contact me. Okay, so this is currently we also collaborate for this particular project with Bonsiu Honda company under transport complex system and near miss situation. And finally, this is very important because we are talking about more on the Internet of Things, big data, data analytics, and simulation toward road safety system. So for here, what we are doing, we are going to create like this, but this one will will be done as a portable device that controlled by the particular agency, like road safety agency in Malaysia. And from that, we can access of, currently we're just doing for Penang. Penang is one of the state in Malaysia. Okay, we're doing for Penang on Penang traffic data. And from there, we find what is the blind spot and near miss. I will let you know what is blind spot and near miss. And from that, we will update the monitoring system as a layer, the first layer. The second layer, we will determine the environmental sustainability through big data and road policy solutions. Third, we're going to do on equitable economic development or improve the safety using the CCTV data and using the image processing from the data. Definitely, when you're saying image processing, you need to do classifier, which is artificial intelligence. And finally, we can do as standard operating procedure. And if you look here, Malaysia, Thailand, Vietnam, and Indonesia is actually quite similar in the similar range. We are a very high country that towards to the accidents. And that's why what we are doing, we are integrating our image processing and cloud computing and using machine and deep learning to do optimization. And finally, we look at the microscopic, macroscopic, or mesoscopic conditions of the roads. And here we can use the system not only for high predictions, accuracy, or advanced safety technique. We also can be used the system for autonomous vehicle in order to save distance, cost, and time. So basically, this is what currently we already done. We will start this project on 2019. We already identified black spot. Black spot means what the condition of the road will make towards accidents in future. Next, we do modeling and forecasting using big data and IoT. Currently, we're doing SOP road safety. We are collaborating with our governments, the local governments here, to implement the software policy when you are doing CCTV monitoring. And we, in next year, actually, we're using to improve the safety. And finally, our aim is we'll finish at 2024, where we will doing web or Android application for monitoring and maintenance, same what have like in the waste. Okay, so this is the power of enabling the data. That's why I'm saying I always believe with the data and power of the data, and the method that we are using, artificial intelligence will be one of the most used tools to predict the data. So current methodology, why we need to have the CCTV? Current methodology, I don't think is only in Malaysia, even in other country. Most of the road only can be solved, only can be repaired after 10 years of the proving, and also after the next RMK or the details after the argument in the parliament. So if we take around 10 years when you're using current methodology, using by local government agency, and this will make more accident, more black spot, near miss, and fatality or crash will be happen. That's why we need to enable the data by using the data from hospital, from CCTV data or insurance company. We can do real-time sharing system when we need to collaborate with particular local government agency to do the database. And from this database definitely will help to do to understand the pattern, to understand the action, awareness, and intervention. Definitely will be the reference point for any system development. This is our progress currently. Currently, we already do for using 3 years data and artificial intelligence, and we implement in our Google Map and do our own coding so that we can determine which is identifies a black spot, crash fatalities that will have high probability that will have road accidents. And from here, we already can save around 80% of the road safety to take into account. Okay, and next, this is the website that we are start to develop on traffic accidents database and analysis system. So this one is to handle the police report accidents data in Penang to make them can work in geographic information system. That's why I'm agree with Prof. Helen just now. Geographic information system need to be considered as an important tool in predicting of road accidents, and definitely by using computer software, efficiency can be greatly enhanced, which becomes a valuable topic under study. So this is what is going on in Penang. From the data, currently we have real-time data. We can know when it happened, why, what the patient name and the case name, when it happened, weekday or weekend, the time, peak hour, road category, is it what type of the road, and definitely from all of these data, we can implement into our TADAS integrated accident map, and we got GPS location, and we are using crash referencing system for highway. Okay, basically we start to do for highway, then we're going for local road condition, because for highway, we just consider as a big vehicle because the complexity will be very less compared to local street roads, which will have motorcycles, which will be very complex into do when we are doing the modeling or artificial intelligence system. So this one will help to reduce the fatal crash in Penang, incidence index in Penang, emissions of carbon, maximum use of images and big data analytics, and we also can do vehicle density tracking and speed. And this is one of the computer artificial intelligence, simple artificial intelligence that we can do for volume count traffic data collection, what currently I'm doing for Penang data. So it just using a simple, it's not considered simple, but still so-called simple transport counting system. Currently, what happened in Malaysia, I don't know what happened in Indonesia or California, but in Malaysia, they take manual data. They just do sit there and observe to take the data. But now, using this system, the local authority may need to save around 23% of their total budgets in order to do the data counting and also the type of data tracking in particular area in Penang. So this will be very much good work that that we can implement more. So this is the next ongoing project with my students. What we're doing is we particularly identify what happened for crash referencing system, or what the probability the particular car in a particular road will involve with the accident, and also definitely will involve with the artificial neural network of conventional neural network. Definitely I'm using conventional neural network and also fast RCNF, okay, because this is as a classifier which will help on the bounding and also predictions. Okay, so let's look another simulation from artificial intelligence for that particular road in Penang, and from there we also can identify the start or end point of using Lee-Hilbert kernel hybrid space. Definitely using our modified algorithm in order to find the safety nets of the bottlenecks. And definitely using this particular method, what we do currently, we use a lot of video. This is a particular video from Beijing, China. A lot of video, we collaborate with China, one of the China university. Okay, we do on image processing for the particular road, and we can convert this road into the system where from here we can find our simulation, acceleration, simulation gap, and also the time, which can be used to do the prediction using our proposed algorithm. Here we are using genetic and SPSA algorithm. And this is another type of artificial intelligent driver model. This is very important, especially for autonomous vehicle, where we can implement artificial intelligence. And this is another pattern, online going project. Sorry, is a basically important project that conducted by me in Penang, and the project is already identified as a good or impact project. now they ask us to do for the whole Malaysia. Okay, so for this project, we not even only looking at the big big vehicle, but we also looking at the small vehicle, including motorbike, and it gives us a better predictions when and certain accident will be happen. And from that system, we already developed a software which will give us the collision event and also the GIS map that where is the particular road. And from here, we can understand on the road behavior pattern at regional location. So this is our final our future direction of collaboration. We are now doing on TADAS able to identify on third and fourth phase. Basically, we are now doing on friend user application. We have public can put a lot of things like in the waste as an initial layer, but will be monitor control system by a local government and highway agencies, and they will filter certain layer, and finally our aim to reduce the number of accidents and in the real-time system base. Yes. Okay, thank you for the listening. That's all from me. Please come to University of Science Malaysia. We have a lot of projects going on, and I will be very much happy if you can join us into the project. Thank you so much.
Thank you very much, Dr. Majid, for deliver your presentation. It's very informative and interesting presentation. So, okay, for the question, you can chat on the chat box, yeah, and then you can write down your question in the chat box. So, let's move to the next session. We invited to Honorable speaker, Dr. Rini Nur Hasan. She's from Universitas Brawijaya. With topic research is control system development on electrical power system in COVID-19 era. So, Dr. Rini, you can hear my voice?
Yes, I can hear you.
How are you?
Fine, thank you, Dr. Rocky. Okay.
Okay, Dr. Rini, you can deliver, and maybe I can.
Please just allow me to share screen. Okay. It is not necessary to make me a host. Yeah.
Okay.
Okay. Thank you much. Thank you very much,
yours.
Dr. Rocky.
Okay, thank you so much.
Yeah.
Oh yeah. After you share your screen, and please return back the host to my name.
Okay. I will try later. Okay.
Thank you. The screen is yours now.
Thank you very much, Dr. Rocky Alphonse. And good morning, all audience, all participants of this morning event, the international webinar organized by Universitas Sultan Ageng Tirtayasa under the World Class Professor Program 2021, supported by the Ministry of Education and Culture, Research and Technology in cooperation with the Ministry of Finance of the Republic of Indonesia. And first of all, please allow me to say good morning to the host and my other colleague speakers of this event. And the first one, I would like to say good morning to Professor Fatah Sulaiman, the Rector of Universitas Sultan Ageng Tirtayasa. Good morning, Prof. Thank you very much for inviting me to participate in this morning webinar. And the second one, I would like to say good evening to Professor Helen Yu, the invited world-class professor 2021 at Untirta. It is a great honor for me to have the opportunity to meet you in this morning event. The next one, I also would like to thank Dr. Ali Mudin, my fellow recipient of WCP 2021 funding program, and thank you for giving me the occasion to be here this morning. And I also want to say good morning to Professor Trio Ationo from Institut Teknologi Bandung. He was my younger campus mate at ITP around 32 years ago. Since the time, I think we only met once. It was in 2009 at Universitas Hasanuddin in Makassar. And I want to take this opportunity also to say hello to Professor Tofail Ahmed from University of Tsukuba and Dr. Majid Khan bin Majahar Ali from University Science Malaysia. It is due to Universitas Sultan Ageng Tirtayasa that I get a precious opportunity to know you all. It is an honor to me to make your acquaintance. And okay. So, can you see my screen?
Yeah, it's quite good to clear.
Okay. Okay. So actually, under the topic of smart control system for multi-agent on industrial and agriculture, smart farming in COVID-19 era, the organizer assigned me to talk about the topic control system development on electrical power system in COVID-19 era. So I will try to talk a bit about it and from what I have gathered from many references. So we all know that COVID-19 pandemics produced impacts in many sectors, including social, or economic, and also in energetic impact. I mean, from the point of view of energy. Yeah. The economic crisis caused by the pandemic is forcing the government around the world to enact emergency support to reduce the business activity, to minimize the threat of virus spreading. And we know that it brings more impacts on social and economic level. And from the point of view of energy, there are many changes in consumption pattern being with I have to wait a moment. I have to change the host to Dr. Rocky.
Oh, yeah.
So okay, yes, okay. I put back the okay. Okay. So do you see one screen or two screens in your screen?
Yeah, two screen.
Oh, sorry.
Yeah.
Sorry. Wait a moment, please. I have to set where it is. Display setting. Wait a moment, please. Okay. Yeah. Can you see one screen now?
Yeah, one screen now.
Okay. So yeah, from the point of view of energy, there are many changes in consumption patterns being caused by the lockdown, social restriction, travel ban, and also the activities of working from home and also school from home. And we have known that there are global energy demand fall because of the COVID-19 pandemic. Yeah. Global energy demand is estimated to fall by around 6% in 2020 relative to the previous years. So we witnessed also that commercial load demand dropped the maximum residential load demand increased and industrial load demand also dropped, but not very significant in many countries. And energy demand price dropped in most of the countries, especially in commercial and industrial. The demand was lower. And from the point of view of environmental impact, we could see also that the density of nitrogen dioxide during the pandemic in certain part there is a lower density. Yeah, so it is a better condition in terms of environmental condition. So to countermeasure the impacts, most of the measures announced so far by the governments focused on healthcare and financial support, especially for vulnerable households and businesses. So the economic sectors was really heavily hit by the impact. And I have read that fiscal measures in G20 countries represent around 7% of each country's gross domestic product on average. So many governments of many countries have tried to prioritize the action to fight against the impact of the pandemic. From the point of view of energy sector, the energy sector, we know that it has played a vital role in supporting the delivery of healthcare, remote working, and many other needs. Yeah, we know that during the pandemic situation, electricity was even now is very vital to many activities. Moreover, during the pandemic, especially in hospital and in medical center. Yeah, and we know in this condition also, it is not easy to get in some part of countries. It is not easy to get the primary energy sources which have to be imported from other countries, from other part of the world. So it is very important to increase the shares of the renewable, and it will produce the non-synchronous generation. Yeah, so non-synchronous generation, because we know that in general in central power plant normally many synchronous generators are used. So renewable energies normally we call non-synchronous generation power plant. Yeah. Electricity from renewables could be the only energy source to grow in 2020 thanks to new capacity additions and priority dispatch. In this situation, there are new challenges in power system operation. Yeah, we can't fight pandemic without electric power. We know that, and big shares of renewables become important at local and global levels. In general, we can see two different situations just to know how important to overcome the challenges in power system operation. Yeah. The first one, in situation one, it is not specially in Indonesia, but it can be in other part of the world. Yeah, that there is a system. There are two systems which is connected together. The first system is dominated by synchronous generation. Yeah, and the second one is dominated by non-synchronous generation, for example, from renewable energy. Yeah. And if there is a system like this, there are some challenges that need to be considered. And for the second situation is the situation where in a system the domination of non-synchronous generator is very clear. Yeah. So it brings also its special challenges being important to be considered. Yeah. In the first situation, we can see some challenges that to be overcome, including voltage control and also low voltage right through. Yeah, it is the condition where when the condition of voltage is dropped, yeah, it must be protected in order not to be disconnected from the system. And also about the power quality, yeah, it is also to be considered. Low short circuit level, power control through interconnection. And for the situation 2, we can see here some associated challenges which can be in local and global, include low inertia, primary frequency control, and frequency stability. Yeah. In the second situation where non-synchronous generation, in general, not like in the synchronous generation domain. In the situation 1, we can use synchronous motor to control the inertia, but in the second one, it has the properties of low inertia. So in situation 1, if we talk about the voltage or reactive power control, yeah, we must set the reactive power margin. So renewable plants must have the capacity to both absorb and deliver reactive power. Yeah. In general, we add capacitors to provide the reactive power. Yeah. Main transformer should also be adequately sized in this case. Yeah. And also periodic verification should be done to ensure the availability of reactive power at very short notice. Yeah, shortly. Yeah. And it is also important to consider the point of interconnection (POI) on high voltage node, but it is not should be too far from the location of the non-synchronous generation, because high risk of instability can be found, yeah, including undamped oscillation, and this situation can bring about the worst case, can bring about the blackout. The second consideration is about the low voltage right through. Yeah, low voltage right through is mandatory in situation 1. Yeah, reactive power support to improve behavior after a disturbance is also to be included. Yeah, and checking for some special settings is needed. For example, in order not to be caused by multiple voltage dips, rate of change of frequency. So it must be protected against the rate of change of frequency, and also phase shift protection. And another important consideration involves the frequency or active power control. Yeah. In the big system, which is dominated by synchronous plants, yeah, it has high inertia, so it is especially the primary control, yeah, that we can use. Yeah, but in the small system dominated by synchronous non-synchronous plants, we call it the secondary. In the voltage control measures, we know that the sudden reduction of load demand during lockdown causes over voltage in the networks, in the transmission and also in the distribution. Yeah. And dynamic voltage control take place at the interconnection and the transmission level. Yeah. The main task of the interconnection network level related to voltage control are including to retain a constant voltage at the power stations, to maintain a stable distribution of reactive power throughout the networks, to preclude overvoltage due to load outages, and also to raise the grid stability at short circuit situation by swelling the excitation to maintain the synchronism of the grid. And in the second situation, where it is dominated by non-synchronous generators, the most important is that we should consider the low inertia environment. Non-synchronous plant connected with our electronics do not add to system inertia. So higher initial rate of change of frequency after generation and load trip can be caused. Yeah. Distributed generators might trip due to anti-island protection. Yeah, if the rate of change of frequency is above certain threshold. And undesired under frequency load shedding due to low frequency nadir, but also the value of rate of change of frequency, which is higher than the certain threshold. And in this situation, of course, it is always important to try to make a stable contingencies, yeah, by making the rock-off less than the threshold. That can be done by redispatching and also bring inertia online, for example, using the synchronous machine. Yeah. And we can also use virtual inertia being accompanied with certain storage. Yeah. But of course, these actions bring about additional costs. Yeah. Okay. And if in the first situation, when it is dominated by the synchronous generation, the primary frequency control is important. Yeah. In situation 2, it is different. Yeah. When renewable shares increases, there will be insufficient reserve synchronous from plants to cover for the largest credible contingency. Yeah, because we know that we do not use many synchronous machine in situation 2. Yeah. In order to provide primary frequency control, renewables would have to keep a reserve margin or have a storage device. So in this case, we can add a reserve margin or using additional storage devices. Of course, it will bring additional cost. And another solution is that the demand or the load or the customer can also participate in primary control through control disconnection. So they can disconnect or their power plant. For example, if we use solar PV, yeah, we can interconnect it with certain rule to the network. Yeah, so it becomes a potential for more flexible market rules. Yeah. And control system must support this function at the power plant level. And it is also important to always doing field tests to verify if the control function is correct. Yeah. And continuous monitoring is recommendable to ensure that plants are operating under the correct modes. So from various references, I I can show you here some general recommendation that especially propose the importance of integration of modern technologies, mechanism, and managerial styles to be incorporated with the power and energy sector. Yeah. For example, the gradual increase of load. Yeah. In this case, if it is not controlled properly, a weak grid may fall to cascading effect, which would in turn create a system-wide blackout. It is also important in terms of fuel security and supply. We know that it is not always easy to maintain the fuel security and supply. The necessity of fully exploiting local fuel potential, including renewables energy sources, becomes very important. So it is better to explore the local potential fuel as well as renewable. Yeah. And it is important during the pandemic situation or even after to support the renewable sector. Yeah. And as maybe some of us experience, it is not easy to find out a certain component during the pandemic situation, during the restriction of movement, during the pandemic situation. So investment in renewable energy resource manufacturing is very important. Microgrids is also important in terms of making the supply, the power supply, more reliable. In terms of energy efficiency, it can be done. Energy efficiency measures can be done since the production, the generation, until the utilization of the generated electricity. And it is very important to building long-term resilience. In the uncertain situation during the pandemic, it is not easy, of course, and it brings about the many possibilities to research about the long-term resilience. And very important is the digitization of the power and energy sector, from the generation until the utilization. In residential sector, commercial, or even industrial consumers. And using the technology as what have been presented previously, smart grid is very important to be explored also. And demand side load management, it is also recommended. It allows grid operators to balance intermittent electricity generation from solar and wind plants, which give a boost to renewable energy sources. And finally, as conclusions, we can see the importance of energy sector for recovery during and after the COVID-19 pandemic era. And it is also very important to control the renewable shares to ensure the resilience and sustainability. And the use of innovative technologies are the keys to boost the transformation of the power and energy sector. It is some references that I used, and thank you very much for your kind attention.
Thank you very much, Dr. Rini, to deliver your presentation. Yeah, I think this is a very interesting to to make the recommendation. Okay, okay. For the next session, we can invite the presenter from Sultan Ageng Tirta Yasa, Honorable Dr. Ali Mudin, Yeah, Dr. Alimuddin with topic research is smart farming in industrial revolution 4.0. Yeah, in COVID era. So, Mr. Alimuddin, you can hear my voice?
Okay, yes. Okay.
Okay. Are you ready to deliver your presentation?
Okay, yes.
Okay. Okay, Mr. Alimuddin, the screen is yours.
You my host now.
Okay, now you are a host.
It's okay. You see my presentation? Hello?
Okay,
Yeah.
okay.
Yeah, okay.
Okay. Yes. Assalamualaikum warahmatullahi wabarakatuh. Good morning and good afternoon. Good day and maybe good evening in California, Prof. Helen. Honorable Professor Dr. Helen, I think you're fine for now, today. This is also from Professor Ahmad Tufail from Tsukuba University, Japan. I think they just now joined here. Also Professor Associate Professor Dr. Majid from University Science Malaysia. Honorable Professor Sri from ITB Bandung. And also my colleague Dr. Rini from Brawijaya University, and also their our participant is a seminar today. I think this my short presentation, Mr. Roque, because Professor Tufail Ahmed, I mean, is already delivered the presentation. My presentation, I mean, just want to their about information, my research 10 ago until now. Any the agriculture, smart farming, agriculture, business and animal husbandry, and building food security independent to our industrial revolution in COVID area. The concept, I mean, there yes, food security. I mean, the source found any the four aspect, any availability, I mean Indonesian ketersediaan, accessibility, I mean keterjangkauan, utility, I mean the facilities, and stability, I mean the continuously, I mean the keberlanjutan. I think this, I mean the four aspect or want to know, I mean want to the implementation. What about to organize, I mean the food, for example, the local food innovation in Banten, Indonesia, and the world also. This is the roadmap actually in Untirta, and the Center of Excellence local food innovation, and the 2070 until now, we, I mean, already to research, including my title, including also the, I mean, the roadmap, smart farming. International smart farming in the, it's been the 2040. I mean this actually, I mean the, in my mind, not the start smart farming. Smart farming maybe the 20 ago, in here, Professor Tufail Ahmed developed in Japan, also in Europe and America also, maybe instead, also Prof. Helm here. It's the conventional or modern farming agriculture. Redness, the human resource and equipment resource. Why there are the two aspects? Because there want to the now in general Indonesian, for example, because country development not like in Japan. The Japan is a modern country. Is in general conventional. Is modern maybe 5 or until 10% maybe, Mr. Rocky. In Indonesia, maybe the research. The research and development, for example, the Ministry of Agriculture, and also the farmer. Not all the farmers in Indonesia. The modern, but in general and conventional. So the remind how to the modern farming and smart farming to Indonesia. The framework smart farming. We can do it. The facilities and also the AIT and also the control. We can do begin or start the pilot project until the field. Until the industry, because this is the big project we want to the success to smart farming. I think is aspect IoT smart farming in the management aspect. Especially the facilities. The in field and also the environmental. Actually this hot issue. Now in the world, also the national competitive also and regional. The research, my experience and the aeroponic, hydroponic, or vegetable cultivation in greenhouse, and also the application smart farming, the cultivation piece and combined vegetable aquaponic system and greenhouse also. In my simulation, the next my presentation. This is the especially for the closed house. And the tools and the many poultry house. Closed house. We can the monitoring and control. The two aspect we want to know: software and hardware. And the control knowledge and the climate knowledge, input output knowledge in the microcontrol and sensor also, and also the poultry knowledge. Poultry knowledge, especially here, discuss about the broiler closed house. Broiler closed house, is good of development. The Indonesia, maybe also in the world, Japan, and also in Malaysia, maybe. And this is my PhD research here. This and the how to the supervision control temperature, humidity, light intensity, carbon dioxide, ammonia content level. We can we won't use the control. It's a good help the broiler. The house, closed house. Growth one month, but not monitoring. We do not the monitoring or control. Maybe the growth 2 months or yes, 2 months. Not it's got to have, and this there is novelty about my is one of my research. And this is the describe about my research, the control the environmental closed house for broilers. And this simulation, I mean the condition, because any three condition, I mean the cultivation for growth broilers, and the first week, the second week, and the third week, and also the fourth week. Any the different condition, for example, the first week, we need the stability of control for temperature 30. But the set, I mean the system at the set point. I mean also the partner of broilers in the world. I mean in regional also. And the second week we need 25 Celsius, and the set and until the 4 weeks we need 25 Celsius derajat. I mean the degree. I mean why we use or do that because the broilers, they need the temperature is in another, I mean different condition. The first week, the second week, the third and 4 weeks. Even though I mean we must then use the control and monitoring, because as we don't use the control, as many broilers is died. I mean the challenge. I mean the virus of broilers. This is an interconnection supervision control. I mean the room. We can the integration. I mean the parameter temperature. I mean the environmental. I mean the temperature, humidity, ammonia, and so on. The next, and my research from the Ministry of the Agriculture. This is a collaboration from it's one of the institution, the Harvest, the Ministry of Agriculture in Indonesia. We together, I mean the smart control temperature, humidity, aeroponic system for greenhouse. This is my experiment. I mean the 2 years. I mean there is one of the research grant project 25-26 Ministry of Agriculture. This is also we build also a greenhouse, prototype greenhouse, and also the prototype and aeroponic, and also any the microcontroller, in the sensor of temperature and the sensor of humidity. I mean the integration, not separate but integration. I mean the sensor of temperature and humidity. Also ammonia and carbon dioxide. But this is just I mean the describe temperature and humidity. This, for example, want to the smart farming system agriculture. This is for example embedded system. We can design the microcontroller and sensor also. And right now we doing the research about the wireless sensor networking. Wireless sensor networking is the multi hydroponic or multi aeroponic, multi hydroponic and multi greenhouse. We can the monitoring. I mean the distance 2 kilometers or until 5 kilometers. This is one of testing Wi-Fi and so on. It's one of also like the temperature dioxide carbon using the I mean the SAWI plan media aeroponic system based fuzzy logic is one of the artificial intelligence fuzzy logic. Actually, we can develop also AMFIS and also the artificial neural network. I mean, this is one of from the artificial intelligence. This is the control and monitoring for our aquaponic. Aquaponic in the plant also red chill, also the fish. I mean the integration. we can use the integration of control. And also, this is any monitoring smart farming and the field, and the red chill, also the vegetable. We can in the condition COVID area, we can use growing hydroponic or aeroponic plant in the jar, maybe, because in the COVID area, we can the touch, our body, we can just the ground to grow, the plant by hydroponic our home. I think this is one of the contribution smart farming the COVID area. It's necessary to buy vegetable in the shop, the market. Yes, we can do our the jar, in front of our house or behind their house. We can they develop about this, because I experienced also my house and era COVID pandemic. My greenhouse also aquaponic, and also the cultivation for fish, also the cultivation vegetable, and every month we have we can eat the result of the growing in the year my house. I think that's all, Mr. Rocky, my presentation, because maybe Mr. Professor Dr. Tufal Ahmed want to the present. Because we are here from Untirta. Maybe I think that's all, Mr. Rocky. Yeah. Assalamualaikum warahmatullahi wabarakatuh.
Okay. Thank you, Dr. Alim Mudin.
Yes.
For your presentation. Yeah. Okay. We move to the next session. This is the final of the last speaker. We can call Honorable Associate Professor Tofail Ahmed. He from University of Tsukuba, Japan. So I will call to. Oh yeah, Mr. Alimuddin, can you change the host now?
Okay. Okay now.
Okay.
Mr. Tofail.
Okay. Professor Tofail, you can hear my voice. Huh? Hello, Mr. Tofail, Professor Tofail. Hello. Hello.
Maybe the signal.
Yeah, Professor Tofail didn't respond. Prof. Tofail.
Yeah, can you
Oh,
hear?
yeah.
Okay, thank you. Okay,
thank you, Prof. Tofail.
Okay. Thank you very
Professor Tofail, who are you?
Sure. Should I share my PowerPoint?
Okay.
Please. Professor Tofail,
Yes.
maybe you can record the page before the presentation. Record, because you are your host now. Become record.
Oh, should
record.
need
Okay.
to record it?
Okay. I'm sorry.
Okay.
Okay. Yes. Okay.
It's recording, right?
Okay.
No?
Okay. Yes. Okay. Yes. Okay.
Okay. All right.
Okay. Yes.
Okay. So should I start now or it's fine?
Sure, you can start now.
All right. Okay, yeah, thank you very much for introducing me to a nice conference and a good initiative to understand about the smart automations. So I'm Tofile from University of Tsukuba. So I would like to talk about smart control and monitoring for agriculture in Panatomics. So let's go ahead one by one. If we look out, we call it South and Southeast Asia, right? If you look out, the major populations are living in this zone. So it has an issue also, the climate change. The people are suffering a lot for climate issues. And at the same time, the fastest growing populations are living in this area in the world. So I think one of the most affected areas in COVID is in this area. And another main challenge is the labor shortages. So labor shortages is a big deal in this area. So due to the pandemic, we have seen the production has hampered due to the labor shortages there. And what we can do this sort of challenges, what are the smart automation we can use over the time? So a couple of things we look out if we go ahead over the time. One of the point is we call smart control systems. So as some of our colleagues already mentioned, Dr. Ali also mentioned some of the smart control systems and how to bring a solution of such challenges. One challenge is the climate change issues, another challenge is the labor shortages. And definitely that linked with the sustainable development goals. So addition to the smart control systems, we need to talk about also big data analytical platform. So we must need to deal two things, smart control systems and big data analytical platform for the large scale productions. So today's presentation, mainly I will talk two things. One is a micro scale, how we can do the smart control systems and how we can do the big data analytical platform for large scale data set handling. So both are related in the production management in-house as well as the large scale ends. Let me go ahead with some of the things. I think we have been working on smart controls and autonomous systems and leader-follow systems since many years. So we try to develop some of the work, how we can use agricultural vehicles to meet the challenges of the laborers in Japan, especially. So some of the presentations I will show up you. So we have been working sometimes before that to bring out different solutions for automation in farming systems, such as the driverless tractor, how the driverless tractor could support in farmers and the farming communities. So our research mostly focused on visions and lidars. We have used mostly lidars.
Ini robot ini lihat nih, banyak robot
So,
gitu. Wih.
yeah, if you look out carefully, this sort of research we have been already work up with some companies in Japan now using orchard-based systems, how we can use orchard and using landmarks, and the lidars can be used for this sort of navigations when GPS has interruptions. So some of the part we have also worked out some of the crawler-based vehicles, how it can move up on the different levels of movement in the terrain areas. So our research, this research now we are taking out with the industry level, how we can bring out in the industry levels of collaborations. So if you look out this research, we bring out industry level of collaborations using cones as a landmark to run inside in the orchards. So this is some of the places where if you look out, there are some spatial orientations. We can plant like orchards, rubbers, or palm oil plantation in some way that can help to stop over. So we can have those algorithms to work out. So let me move a little bit forward. In addition to the driving systems, we also work for the safety systems, how we can utilize the safety systems for the farmers while they work out. So one of my PhD students, she worked on a face tracking systems. Face tracking means if farmers, they are using the machines in the farm level, if they have any health conditions which needs to be followed up, we can also work out those. For example, a farmer, if they have a blinking, if he has a look back, if he has a look right or left, or if he has a nodding means sleeping almost, right? Or like a yawing. Now our students do that a lot of these sort of things while they're taking class in online. And there is also talking about phone, and also there is like a fatigue. So there are several classifiers we can choose and work out those sort of steps. For example, if you look out not only for farming, but also the road conditions are also very important to reduce the accidents. And this is some of them. You can look out like the roads are very narrow. It creates also the accidents. So how to prevent the accidents, how to minimize the accidents, we started to work out on the face tracking systems. So we use Hankel-based face tracking algorithms to determine the face tracking actions. Okay, so let me go at our this research. Actually, we started after you have seen the robots with some companies, our team. So precision orchard management. So how we can minimize the chemicals for the precisions. Means if you look at a beautiful apple that comes with a lot of spray. So our one of the target to reduce the chemicals. So this is one of the part. With that one, we started to work on development of speed sprayers with the company from Mitsubishi, Maruyama, and National Agricultural Centers. And then this is the how to reduce the chemicals in the orchards. So with this one, we are still working with the project to develop this one based on LiDARs. So we have several groups. Some groups are working on LiDARs, some groups are working on like a GPS-based systems. But GPS has disadvantage of some case, but especially for apple production, there is much facilities to work out with the GPS. So this is the two target, one to reduce the chemicals, second one to use the driverless one. So in the second phase, sorry, maybe this one, if you look out, this is last March, our team have developed work systems without human driverless. Based on that, what the vision, there is a vision systems to work out the reference vision. So this research is still ongoing with the Japanese machinery companies, especially Maruyama companies. So we are still working on for 600 liters and 1,000 liters. Okay. Next phase, I would like to introduce some of the research of our leader-follower combination. For leader-follower, if you look out in agriculture, we usually use similar types of production systems. One is a leader and there's a follower. Once it filled down, then we need to move out. So this is a common for forage harvesting, for maize productions, a common, not for rice, you can see much, especially when there is an issue of forage, like either maize or things that we usually carry over a lot. So this, you can see the formation, leader, follower, leader, follower, leader, follower. Someone is leading, someone is following. So this sort of robot we are trying to use maybe in many aspects is possible. So we started to work on small scale based on YOLO-based target to understand the different sorts of labeling and things. Then in a prototype scale, one of my PhD students who worked on to develop this is a human-driven, this is a follower, so it follows the human-driven one. So we call this a leader-follower systems. That's like, so there is a much chance you can reduce the labor shortages, at least one driver to follow numbers of vehicles. So in our future target, we are trying to work on these sort of things to control by UAV, by the drone. So our research is still ongoing, how we control this sort of small vehicles to controlling the swarm application, multiple numbers of small robots. Let me focus another research. One of my master's students, he completed this sort of leader. Leader is a human, follower is the vehicle. So it can follow and carry lots of stuff, right? So he animated the video in Adobe. So carry out the stuff in a small scale of vehicle to carry things. So there is a more chance to work out for this sort of small scale of vehicles. So as a first phase, we worked out and he developed a vision-based system based on 3D camera. So if you have a small vehicle and it can follow, stop, follow, stop, follow, and then to carry out the stuff. This is like the scenario to carry out using some sort of small stack. So usually it's the intelligent systems of machine learning, deep learning part to detect the human part. This is called YOLO-based human detection. So where is the location of human and what's the angle? And then the follow-up. So we started to work out this one. And then my student got a job and he went to a company. So now we're still struggling to start up the new way to bring out the new research ways. So these are some of the leader follower tracking system for human based. Okay. So let me go to the second part of this one, how we can use the remote sensing part for the deep learning, which carries off with infestation and spraying a lot of chemicals that involved. So we have been doing some research based on UAV-based application, especially for seed broadcasting and spraying. So how, because in Japan, we use a transplanter, we use the seedlings in many of places, maybe in Indonesia, you also do the same, but whether we can use these sort of things a lot. So let me go ahead with this sort of, we call is a UAV, which carries over a seed regulators, and you can broadcast the seed on the top. So you can see after the broadcasting, I did some Pix4D analysis and developed the orthomosaic map, you can see. And this is, you can see the seeds are coming soon. So these are the seeds are coming. I'm not sure about the resolution to the other side, but we usually use the seed broadcasting. The whole field takes 5 to 6 minutes to broadcast the seed. And compared to a transplanter, it has much more cheaper, definitely. A transplanter may be 6, 7 times or 8 times expensive compared to a drone. So drone, it can be used for seed broadcasting. It's quite simple and very easy. And after that, we tested for the germination density and things. Still not promising, but there is a more chance to implement this sort of research in future. You can see seeds are coming down. Okay, so this is another one, the same field. After a few months, maybe 2 months later, the seed germinated as a seedlings. You can see very green and things. To use the same drone for spraying pesticides. So the advantage of these sort of systems, you can use $7,000 US with such a UAV and can be used for pesticides, can be used for seed broadcasting, can be used for like a developing mapping and the monitoring things. So it has the additional advantage to do so. So you can see that there's the nozzle orientation you can change. And there are three nozzles, 1, 2, 3, covered up like a 1.5 meters to 2 meters. The whole field cover usually takes less than 10 minutes for spraying. You need to load it. You cannot do like a long term because it's only a 10-liter tank. So it has the more advantage to do the spraying the pesticide. The same field where we collect where we distributed the seed from the drone. So it has the much more advantage compared to the transplanters. But transplanter has a higher efficiency of seedlings germination. Another problem we noticed, this weed distribution, because when you use a transplanter, it's a row. But when we use drone, it cannot be any more raw. So we need to, how to say, a little bit compromised with the weed, because weed eradication is very difficult with the UAV broadcasting systems. Maybe one of the things we can use the herbicides is the drone. That's the chance, but the problem of the drift and so in the machine learning part, we use a lot of machine learning. My students, they're working a lot of machine learning. We are using deep learning, especially CNN, MSM, and AlexNet. Nowadays, we extended CNN, FASTA CNN, Masca CNN, and yellow-based CNN. So we use the numbers of deep learning process in the automations. So this is one of the examples to classify spray and non-spray area based on the deep learning. This is another one to classify cabbage and non-cabbage area to what to spray, what not to spray based on the spraying systems. So if we look out, I wish this should work. Maybe this is not working. Okay. So this is one of the video we took from drone, and you can see some part, it's called weed density, 53%, 50%, for 56%. So we can identify based on the frame. So based on the frame, we can also control the proportions what we'd like to apply. Similarly, you can see weed proportions. So density level high, middle, and the low. So we can also organize our nozzle distributions, what we spray accordingly. So these are some of the classification accuracy and the loss based on the different machine learning algorithms. Okay, let me go ahead a little bit further. This is some of the research we try to do. We use yellow-based CNN to detect the cabbage. So large cabbage, small cabbage, and medium cabbage from the drone-based imagery. The result not came out very good, I think. There is an issue because when the cabbage grows, it lives like a widely bloomed. If there is some gap, there is a possibility, but if there is no gap, then it's very difficult to determine the grading of the cabbages. This is the remote sensing part. One is a machine learning using UAV. Another is the remote sensing, how we can do the remote sensing. There's two things. One is a vision, one is a remote sensing. And deep learning is not like a remote sensing. We use mainly the vision-based images. Remote sensing part, we try to use a multispectral band camera through the UAV. So it might have more than 3 or 4 band. So you can see this is a plantation field, Ocha plantation, green tea plantation field in Ibaraki. And you can see one of my students is also from Asia and one student from Japan, trying to find out like leaf distribution, the quality of the leaf. If the chlorophyll content is very high, they are actually taking the measurement of the chlorophyll and trying to connect the chlorophyll content with the main scene. So you can see the classifications. Oh, sorry. So this in our normal life, if you look out, that means good, bad, and so one part of the area, the chlorophyll content in DPI were very low, is the red part, but the other side was very good. So the quality of the green tea is much better to this side rather than the utmost corner than the north side. Okay, so this is, you can also use, it's called 3D dense point cloud mapping to understand the height, especially this sort of research. I used a lot of forest canopy measurement, forest types. So we try to use, one of my students, she tried to use a